Hello? Hello everyone. Today we will continue to look at a topic in HCI storage. I have already introduced the basic aspects of the disk itself. So next we will mainly introduce an issue related to transmission. Regarding transmission here, we can mainly divide it into two types. Here, in fact, normal transmission. Take for example in our daily life, when we transfer some files. For instance, when you use a USB drive to copy a file from one computer to another. Or for example, the data interaction between a phone and a router and so on. So how can we ensure that this data is transmitted quickly and accurately between designs? This is actually an issue we need to consider in transmission. Previously, we have already introduced some aspects of the hard drive itself. Next, we will discuss how to make data transmission faster and better beyond the hard drive. Here, we will introduce our two main data transmission methods: parallel transmission and serial transmission. First, you can simply take a look at this. The example diagram in the PowerPoint. We can see on the left, this is called parallel transmission, and on the right, this is called serial transmission. In the case of parallel transmission, you can see, let's assume we have 8 pieces of data, numbers 1 to 8. In this part, parallel transmission is equivalent to what? It's equivalent to us simultaneously. Yes, simultaneously sending out, 8 data packets are sent simultaneously. And on the right side, we only have a single line, right? A single line will also show the values 1, 2, 3, 4, 5, 6, 7, 8. Sent sequentially from left to right, one after another. It's equivalent to a single line. In this way, everyone can clearly see what the issue is, right? The one on the left, right? Its efficiency seems higher, doesn't it? The transmission speed also seems faster. Here, we will specifically introduce parallel transmission. First of all, the working principle of parallel transmission is that our sending end will split the data according to a certain method. It sends them separately to the corresponding lines, while the receiving end simultaneously receives the data from these lines and combines them to restore the original data. For the original data, let's assume it's like this, from 1 to 8. However, during transmission, it will split these 8 pieces of data into 8 parts and send them simultaneously. After transmission, it will combine these 8 pieces of data back together. This is the entire transmission process. This is the transmission process. This is the working principle of our parallel transmission. Its advantage. Well, we can see that the transmission speed is very fast because we can transmit multiple data bits simultaneously. This is very good for scenarios where there is a very high demand for data transmission speed. For example, in what situations? Data transmission between the CPU and memory inside a computer. Here we are not even talking about the hard drive. The speed of the hard drive is too slow. Here the data transmission between the CPU and memory generally uses this parallel transmission method, which can quickly process large amounts of data. Of course, there are also some disadvantages. The disadvantage is that it requires multiple transmission lines, so the cost will be relatively high. And there might be interference between the lines, which means the layout and maintenance of the lines will have higher requirements, relatively speaking, because there are 8 lines. As shown in the picture, we have 8 lines, which is equivalent to. We are transporting from the warehouse on the left to the warehouse on the right. We dispatched 8 vehicles simultaneously to transport, right? On this side, with our serial approach, we only dispatched 1 vehicle. The speed on the left is obviously much faster, but it also costs more money. This is one of our considerations. A basic characteristic of parallel transmission, and one of its usage scenarios. Next, let's take a look at the serial transmission on the right. We can see here that it's equivalent to a single line. And with this line, we transmit the 8 pieces of data one by one. It's equivalent to, yes, the data can only pass through one after another, in sequence. In this case, it can only transmit 1 data bit at a time. But the line is relatively simpler, as it only requires a single line to complete data transmission. In this way, it's cost the expenditure for this. Funding. The relative cost will also be somewhat lower. The working principle is actually that our sending end sorts the data in a certain order, and then sends it bit by bit onto the line. The receiving end will also receive the data in the same order. And combine them into a complete final data set. For the 8-bit binary data we just mentioned, it will start from either the highest bit or the lowest bit and transmit bit by bit along this line. Of course, to ensure the correct transmission of data, some control information is usually added to the data. For example, start bits and stop bits indicate where to start and where to stop, so that the receiving end can better and more accurately identify and receive the data. This is our innovative transmission. Its advantages are that the circuit is simple and the cost is low. Moreover, it has strong anti-interference capability because it only has one line, so there are no interference issues. Its advantages in long-distance data transmission, such as transmitting data through network cables. In such cases, serial transmission is widely used, although its transmission speed is relatively slow, which is quite normal. Right? It only has one line, but because it can only transmit one bit of data at a time, it takes longer to transmit large amounts of data. However, the cost is relatively low, and there aren't many interference factors. This is our serial transmission. Now let's summarize and compare the two. First, looking at the transmission speed of these two. Right? Parallel transmission is definitely faster. This is quite normal, because it can transmit multiple data bits simultaneously. In terms of cost, parallel transmission is also higher, because we need multiple lines here. Whereas here, there's only one line, right? The cost is relatively low, and the commonly used lines are simple. In terms of anti-interference capability, serial transmission has a greater advantage here, because it actually only has one line, so there's no issue of interference between multiple lines. In terms of application scenarios, parallel transmission is more suitable for internal data transmission where high speed is required, and the distance is relatively short. Generally speaking, the distance should not be too long. If the distance is too long, the cost will increase greatly. This is the first point. Secondly, if the data is too long, it may cause some interference problems. If the line layout is unreasonable, it may cause some interference, which is not suitable. So in this case, parallel transmission is more suitable for internal data transmission with high speed requirements and short distance, especially CPU memory, which is close to each other, so we can transmit it quickly, right? Let's open the bug port and transmit it together. Open the bug line and transmit together. As for serial transmission, firstly, it is more suitable for long distances, because it is not affected by, interference between different lines, and the cost is relatively low. Therefore, it is more suitable for long-distance transmission. Moreover, it is quite suitable for situations where, the budget is insufficient or not high. Hey, if we can only support one line, we can just use our innovation to make it work. Of course, this kind of decision should actually be based on your actual needs. Choose according to the actual requirements. Everyone can think about it. If we are transmitting a large amount of data between two devices that are far apart, and in a situation where cost control is quite strict, which option should we choose? Everyone can think about it. What should we choose, Actually, we should choose our innovative transmission. In this case, actually, Distinguishing between different application scenarios is actually quite simple, as these two options are relatively distinct because their characteristics are more apparent. To summarize, when making a choice, if your transmission distance is long, you can choose serial transmission. If the cost requirement is such that the budget is relatively low, then hey, choose serial transmission. If the speed requirement is very fast, choose parallel transmission or kalröçeim. If the distance is short, you can also choose parallel transmission. If the cost is sufficient, choose parallel transmission. Basically, based on cost, distance, and transmission speed, we can make some choices. Depending on which aspect you value more, you can choose your focus. Focus on whichever aspect you prefer and choose accordingly. This is our, 3 or 2 methods of transmission. When it comes to choosing a specific method, it depends on the actual situation. Actually, what is the most important point? The most important thing is actually the cost. No matter what it is, the most important thing is the cost. So, first consider the cost. And once the cost is not an issue, then consider the distance and also the speed. Alright, this concludes the main content for today. If anyone wants to learn about Huawei cognitive technology or obtain the Huawei certification question bank, please send me a private message or leave a comment below the video for further discussion. Okay, let's stop here for today.